What's up, my friends? Welcome to a video on the basic derivative rules. So this is in the intro to derivatives section, basic derivative rules coming right at you here. So what is this lesson all about? Well, in the last couple lessons, we used the limit definition to find derivatives, which is a great definition. Listen, I love it, but it takes a lot of time. So once again, the limit definition is saying, hey, to find the derivative of a function f of x, I got to take the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. And what we've noticed is that using this rule or using this idea to find derivatives takes a lot of time. And as the problems get more difficult, it takes even more time. So first off, what we want to teach you in this video is some, I guess you call them shortcuts, but I'm going to call them rules. Rules to help us find derivatives faster, quicker, and easier. This is where derivatives get really fun. Now, what I want to make sure I'm also clear on is that what we're going to learn, they're called differentiation rules, right? Differentiation is the process of finding the derivative of a function. So to be honest, like what we've been doing is we start the function and we start the process of finding the derivative. That process of doing the math work to find the derivative is called differentiation. Taking a function and finding its derivative. That process is differentiation. So what we're going to teach you is some differentiation rules that make that process so much faster, so much easier. And there's several rules, and there's actually even more videos in the future here for rules. But in this video, we're going to learn several rules. And even at the end, for some more advanced problems, we might have to actually use multiple rules at once. So some problems incorporate one rule, some problems need more than one rule. But that's what this lesson is all about. Finding derivatives, the process of differentiation, faster, easier, and more fun, to be honest. All right, so before we begin, though, we got to talk about how do you denote what a derivative is, just because there's a couple different ways to do it. The way that I've taught you thus far to denote a derivative is f prime of x. So you put that little whatever accent, whatever you want to call it, put that little apostrophe is what it looks like, but it's an accent. That's f prime of x, right? But another thing we could do is we could just say y prime. Remember, f of x and y are the same thing, so we're used to using f of x to define a function, but whatever. F of x is the same thing as y. We've been saying that since algebra. So instead of putting that little prime on the f of x, we could say y prime. And there is another third, more advanced way, and that is being very descriptive. And most kids don't like this way, but this is used in a lot of upper-level calculus. It is saying, hey, here is the derivative of y with respect to x. So you're saying the derivative of y with respect to x, dy over dx. So you're finding the derivative of the function with respect to x. And I know that this is kind of not as fun to do, but this is what a lot of upper-level mathematicians will say. So you're saying d for derivative, the derivative of the function with respect to x equals blah, blah, blah. And that's where you put your derivative, right? So again, the derivative, most of the times, I'm just going to go ahead and use the little f prime. You might see y prime, but again, this is the official way to say, all right, the derivative of this function is, and here you go. So d for derivative, the derivative of this function with respect to x, that's what the dx on the bottom is, and then again, your derivative. So that's another way that we typically see this used. All right, so without further ado, let's get to the rules, because the rules are really the fun part, which is going to make your lives so much easier when it comes to finding derivatives. So the first rule is called the constant rule. It's the most simplest rule in the world. It says the derivative of a constant function is 0. So if c is a real number, then the derivative of c is automatically 0. So if you have a function that is a constant, 2, 4, 7, 3, 1, whatever, the derivative of any constant is always 0. And again, this is just using that new notation. The derivative of a constant with respect to x is always 0. So if you have a function that is just a single value, the derivative is always 0. Very easy rule, nobody ever messes up. Let's actually use it on a couple of practice examples here. So if a function is 7, remember that's just a boring horizontal line that is always at 7, the derivative of that function is 0. If a function is -8, that's again a boring line, horizontal line at -8, the derivative of -8, guess what? 0. If a function is a decimal, 3.2, it's a constant 3.2, guess what? The derivative is 0. What about if a function equals pi? Now remember, pi is a number. It's just a very fancy irrational number, but it's about 3.14159. It's just a number, but guess what? What's the derivative of a single value? 0. And now why does this make sense? Because all constant functions make straight horizontal lines. This one's at 7, this one's at -8, this one's at 3.2, this one's at 3.14159. Great. But think about this, right? A derivative is a formula to find the slope. And a straight horizontal line always has a slope of 0. That is why the derivative of any constant number is always 0. Because I don't care where your horizontal line is at. It could be at 7, it could be at -8. The slope of all horizontal lines is 0. So that's why the derivative of a constant is always 0. All right. Now, this next rule is by far the most commonly used derivative rule in all of the world. It is such an awesome rule, and it's so easy to use. All right. If n is a rational number, then the derivative, then we have the function f of x equals x to the n. So again, that's a power function. Remember, you should have learned that back, in old school pre-calculus, is that x raised to any power is called a power function. So a power function is differentiable, and the rule is very simple. To find the derivative of a power function, x to the n, here's what you do. Very simple. The derivative, f prime, you drop n down in front of the x, and then your new power is 1 less than your old power. So once again, using this new notation here, the derivative of a power function, drop the n down in front, your new power is n minus 1. Now I have a little note down here about the derivative of x. So let's actually use that as our first example. So the derivative of x. So we have this is the most simplistic power function in the world. The power is 1. So if this is my function, x to the first, to find the derivative, I'm going to use the power rule. Here I go. The 1 falls down in front of the x. My new power is 1 less than the old power I started with. So 1 minus 1 is 0. So that's 1x to the 0. So the 1 fell down in front. My new power is 1 minus 1, which is 0. But again, remember, anything raised to the 0 is 1. So 1 times 1 is 1. So the derivative of just x is 1. Very, very simple. Now, what's the theory behind that? Well, it's very simple, actually. So the function x is a straight line right there. It's a straight, very boring line. And a boring line x has the same slope everywhere. Any point on this line has a slope of 1 because the slope of x is 1. And it's always 1. So that is why the derivative of x is just 1 because your slope is always 1. All right, so let's go ahead and use the power rule on some much more advanced problems. But again, a little bit weird, but once you start using it, you're going to love it. It's so easy. All you got to think of is the exponent falls down in front. Your new power is 1 less than the old power, and that's your derivative. So let's do these 5 examples really, really quickly because these problems go so fast, so much faster than using the limit definition. All right, x to the 5th, here we go. The derivative is 5 falls down in front. New power is 5 minus 1, which is 4. Boom, you're done. There's a derivative. Are you kidding me? It's that easy. So simple. All right, let's try this next one. X cubed. The derivative of x cubed is 3x squared. 3 minus 1 is 2. You're done. Yeah, I told you that these are so easy. And it even works with fractions. Now, you might have to slow down and do some work, but it even works with fractions. It doesn't matter. As long as you have a power, the power rule will always work. So once again, the 5/4 drops down in front, and the new power is going to be 5/4 minus 1. And this is I have to do a little dirty work. So 5/4 minus 1 is 5/4 minus 4/4. 5/4 minus 4/4 is 1/4. So my new power is 1/4. There, done, easy. How simple is that, guys? I say it's the most powerful rule. That's why they call it the power rule. All right. So again, let's try this last one here. X to the negative 8. It even works with negative exponents. Doesn't matter. Follow the rule. Negative 8 falls down in front. The new power is 1 less than the old power. So negative 8 minus 1 is negative 9. So there is my derivative. Negative 8 times x to the negative 9. So easy. Let's use the power rule in some more situations. All right, now, a lot of kids would look at this problem, the square root of x, and they would say, can't use the power rule. That's not a power function. You sure? How about we first write the square root of x with a 1/2 power? Oh yeah, remember that from Algebra 2? The square root of x is equivalent to x to the 1/2. And now that it's a power, I could find the derivative with the power rule. Bring the 1/2 down in front. X, my new power, is my old minus 1. So it's 1/2 minus 1. That's 1/2 minus 2/2. That's negative 1/2. There you go. That's it. That's my derivative. Now, it is, mathematically speaking, we don't like having negative exponents left in a final answer. So what I could do, and goes back to an Algebra 2 topic, I can move this x to the negative 1/2 to the denominator where it could have a positive exponent. So I'm going to leave the 1 on top. The 2 is already in the denominator, but now I could write that as x to the 1/2. So there is my function. And then again, you can even do one more step. Again, you don't have to, but you can even do one more step. That's 1/2 times the square root of x. Because remember, x to the 1/2 is a square root. So you could even have your final answer written just like this. And that's a really beautiful final answer. All right, this next problem is kind of the same thing. A lot of kids look at that and say, can't. So it's got a cube root, can't do it. Come on, you learned in Algebra 2 that I could express this function as x to the 4/3. Remember, powers go in the numerator, roots go in the denominator. So the cubed root of x to the 4th is x to the 4/3. So once again, now that it's written as a power, I could go ahead and use the power rule. The 4/3 falls down in front. My new power is going to be 4/3 minus 1, which is 3/3. 4/3 minus 3/3 is 1/3. So there's my final answer. It's not a negative exponent, so no reason to move it. But you could go ahead and say, well, a 1/3 power is a cube root. So you could write it as a cube root. I don't care. You don't have to do that. All I really care about is that there's no negative exponents. All right, another problem here. Now, you got to be very careful with this problem down here because a lot of kids will do this. They'll say, I'm going to use the power rule. 3 falls down, new power squared. No, that doesn't work that way because this, as it's currently written, is not a power function. A power function is x to a power. Sorry, when it's in the denominator, it doesn't count. This is not a power function unless I use my Algebra 2 skills and first rewrite it. 1/x cubed can be written as x to the negative 3. So remember, you can move your variable around numerator to denominator as long as you change the sign. So if it was x to the 3rd in the bottom, you can move it to the top as x to the negative 3. Then I could go ahead and use my power rule to find the derivative. Negative 3 falls down in front. The new power is negative 3 minus 1, which is negative 4. But wait a minute, I don't like negative exponents left. So the negative 3 is going to stay on top, and the x to the 4 will go on the bottom where it could become positive. So there's my derivative. So be very, very careful with these problems, but follow the power rule. Now remember, once that negative 3 falls down in front, it's no longer a power. So it's just a constant at that point. That's why the negative 3 stays on top. It does not move to the bottom. How easy is that power rule? It's a really cool rule that you're going to use a ton, I promise. All right, the next rule is called the constant multiple rule. Kind of a confusing rule to learn, but once we use it, it's actually really simple. So if f of x is a differentiable function and c is a real number, then c times f of x is also differentiable. And here it is, right? Again, the rule's kind of weird to explain, but it's very simple. The derivative with respect to x of a function being multiplied by c. All you have to do, listen to what I'm about to say, is leave the c. Just leave it there. Find the derivative of the function, and the c just stays in front of it. So when you have a constant multiplied by a function, that constant just stays there. That's it. It just stays there. And don't do anything with it. Find the derivative of your function, the constant just stays there. A very easy rule, kind of weird to show you, kind of weird to explain it, but easy to see it in examples. So here we go. Watch how easy this is. All right. So we have x to the fifth times 4. Well, because we learned the power rule, I know how to find the derivative of x to the fifth. So what do I do with the 4? Just leave it there. So the derivative is going to be 4, just leave it there, times, now I'm going to use the power rule. 5 falls down in front. My new power is 5 minus 1, which is 4. So now I can clean this up because what do? Well, the 4 says, oh, hi, 5. Nice to meet you. Let's multiply 20x to the fourth. So again, the 5 falls down in front. The 4 is already there. You leave it there. They multiply to get 20. Done. How easy is it? All right, let's try this one. But once again, if I'm going to use the power rule, the first thing I have to do is rewrite this as 5 times x to the 1/2. Now I can go ahead and find the derivative very, very quickly. The 5 just stays there. The 1/2 falls down. X to the 1/2 minus 2/2, subtract 1, is negative 1/2. All right, so now I do want to clean this up because I do not like negative exponents. So what's 5 times 1/2? Again, that's just a constant I can multiply. Well, that's just 5/2. And then the negative exponent that I don't like is going to move to the bottom where he could have a positive exponent. There is my answer. 5 divided by 2x to the 1/2. Really, really cool. All right, let's try this next one. Once again, the 6 is just a constant, but I can't use the power rule unless it's a power. So I'm going to write this as 6 times x to the negative 2. Again, I'm just going to move it up, but if I'm going to move it up, I'm going to have to give it a negative exponent. That's a rule from Algebra 2, guys. I expect you to know that. Once again, now, sorry, not equal sign, to find the derivative, that's just a rewrite of the function. To find the derivative, the 6 just stays there. The negative 2 falls down in front, and my new power is 1 less, which is negative 3. So that's negative 12x to the negative 3. But once again, I don't like negative exponents. So I'm going to leave the negative 12 where it's at, and the x will move to the bottom with the positive 3. There is my derivative. So stinking easy. All right. This next one is already written. It's a power. Who cares? Fractions could be powers. Doesn't matter. So once again, I'm going to use the power rule to I keep running right an equal sign. Right. Listen, I'm finding the derivative. Definitely not equal to the function. So the derivative is, again, negative 2 is just going to stay there. The 1/3 falls down. And my new power is going to be, again, come to the side, do your dirty work. 1/3 minus 3/3, because you got to subtract 1 to get your new power. That's going to be negative 2/3. So negative 2 times 1/3 is negative 2/3, right? That's this guy right here. That's just a constant. That has nothing to do with your power. Negative 2 times 1/3. And then again, I don't like negative exponents, so that x will move to the bottom where it could become a positive 2/3. And there's your final answer. So easy. All right, now, there's a couple places where we got to be careful when we're working with the power rule and constants. And most of those problems involve seeing parentheses. So all I got to make sure I emphasize to you guys is, really the problem that kids have is not with the new derivative rules. The problem they have is their Algebra 2 skills are poor. So again, if I want to use the power rule, I have to write this as a power function. So the 1/2 just stays as 1/2. Like 1/2 is just a number. 1 is a number, 2 is a number. That has nothing to do with the power. So the 1/2 just stays there. But it's going to be 1/2 times x to the negative 3. Because I want to treat this as a power, so I need the x to not be in the denominator. I need it to be in the numerator or to the side. So that's why I'm going to write it as x to the negative 3. But the 1/2 just stays there. See, I'll get some kids that are bad at Algebra 2, and they'll move the 2 as well. No, the 2 is totally happy in the denominator. He does not have an exponent at all. So just leave it alone. And then again, now I'm going to go ahead and find the derivative using the power rule. The 1/2 just stays because it's a constant. That's the constant rule. The negative 3 falls down in front. So the negative 3 falls down in front. My new power is 1 less than the old power, which is negative 4. Then I'm going to go ahead and do the multiplication of my numbers. 1/2 times negative 3 is negative 3/2. And I don't like that negative exponent, so the x is going to move to the denominator. We can have a positive 4. So kind of an ugly answer, sorry. It's a little bit prettier if I write it as negative 3 over 2x to the 4th. That's my derivative. Now listen, I know that these rules are a little bit tricky and you got to get used to them, but I hope before you complain about these rules, I hope you agree that applying these rules are 100 times faster than using the limit definition to find a derivative. I hope you agree with me on that. All right, let's do another very similar problem here. The first thing I'm going to do is rewrite this function as 4/3 x to the negative 2. Again, the 4/3 is just a constant sitting out in front. I'm just going to rate it as a power x to the negative 2. Now I can go ahead and find the derivative. 4/3 is just going to stick around. Negative 2 falls down in front, x to the negative 3. 4/3 times negative 2 is negative 8/3. And then I don't like that negative exponent, so I'm going to move it to the bottom as x to the positive 3. Boom, there's my derivative. So simple. All right, one more problem now that has parentheses. Now, when you see parentheses like this, what I recommend doing is applying algebra 2 rules, which means just squaring. So this problem right here was 3 times x squared. Only the x was squared. But because the parentheses, the 3 and the x are both squared. So the first thing I'm going to do is simply do that squaring, which is 9x squared. Then I'm going to leave the 2 9s as a constant and write it as x to the negative 2. So I had to take a couple steps to make my function a power function so that I could apply the power rule. Now I can go ahead and find the derivative, and all I'm going to do is leave the 2 9s alone. That's the constant multiplier rule. Negative 2 falls down in front. My new power is negative 3. And then you just got to multiply. 2 9s times negative 2 is negative 4 9ths. But again, I don't like negative exponents, so I'm going to go ahead and move that to the bottom where it has an exponent of positive 3 in the denominator. Guys, that's how easy these problems are. I love them, I love them, I love them. And, you know, you're going to learn them, but my goodness, are they faster than using limits. All right, the next rule, only a couple more rules left. The next rule is called the sum and difference rules. These rules are so easy. Check this out. All it says is this, so easy, don't overthink this. To find the derivative of a function plus another function, all you have to do is find the derivative of the first function and add the derivative of the second function. Like a duh, right? It even works with subtraction. To find the derivative of a function minus another function, just find the derivative of f, find the derivative of g, subtract them. It's so easy. But what's actually even easier is how I'm going to apply these rules. All right, so here's 2 examples. All right, check this first example out. I have a power function, 4x cubed, minus another power function, 2x to the first. So to find the derivative, all I have to do is find the derivative of each part. I mean, it's that easy. So the first part, the 3 falls down in front. And once you guys get good at this, you could skip steps, right? Do in your head, the 3 falls down in front. 3 times 4 is 12. You could do that in your head. My new power is 3 minus 1, which is 2. So there's the derivative of the first part. The derivative of 4x cubed is 12x squared. All right, now I'm going to go ahead and find the derivative of the back. So once again, the 1 falls down in front. Negative 2 times 1 is negative 2. My new power is 1 minus 1, which is 0. Now, x to the 0 is just 1, so there's actually no point in writing it. So the derivative of negative 2x is negative 2. A lot of kids will say, where the heck did your x go? Listen, it was there. When that 1 fell down in front, negative 2 times 1 made the negative 2. My new power is 1 less than the old power. So 1 minus 1 is 0. But there's no reason for me to write x to the 0 because x to the 0 is just 1. So there is my derivative, 12x squared minus 2. How easy, guys. All right, next one. Now, as I've been doing, I'm going to first rewrite this function. I'm not finding the derivative yet. I'm going to rewrite it. Negative 5x squared is good to go, but I'm going to write this as 7x to the negative 1. Again, there's a power of 1 on that x. I'm going to move it up because that allows me to use the power rule. Now all I got to do is use the power rule on each of these parts, and I'll get my answer. It's that simple. So the derivative of this function is going to be, let's see, 2 falls down in front. I get negative 10x to the first. 2 falls down in front. Negative 5 times 2 is negative 10. 2 minus 1 is 1. X squared goes down to x. Easy. All right, now the negative 1 falls down and makes a negative 7. 7 times negative 1 is negative 7. My new power is x to the negative 2. Negative 1 minus 1 is negative 2. But of course, I'm done, but I do want to clean this up. Negative 10x minus 7 over x squared. Remember, I don't like leaving negative exponents in my answer. Boom, there's my derivative. You could go ahead and get a common denominator and add these together, or actually subtract them if you wanted to, but you don't have to. That's a beautiful final answer. How simple. All right, let's do a couple more here. And the good thing is once you guys get really good at these problems, you kind of just start cruising through them. So this function is a power function. It's already good to go. So I'm going to find the derivative. I'm going to use my rules. 2 falls down in front, negative 4x to the first. 1 falls down, makes a negative 5. X to the 0 is just 1, so I'm not going to write anything there. And the derivative of 8 is 0. So I went through that very fast, but let me go through that again. The derivative of negative 2x squared. 2 falls down in front. Negative 2 times 2 is negative 4. New power is 1. So there's the derivative. 1 falls down in front. Negative 5 times 1 is negative 5. My new power is x to the 0, but please don't ever write x to 0. I mean, you can, but x to the 0 is just 1, and negative 5 times 1 is negative 5. So there's my derivative of negative 5x. It's just negative 5. And then finally, the derivative of 8. Remember that goes back to the very first rule we learned. 8 is a constant. The derivative of a constant is 0. So my final answer is just going to be negative 4x minus 5. You cannot tell me that this is not faster than the using limits. This is so fast and easy. All right, this next one is also just as easy. Let's see. Let's go ahead and find the derivative. All right. The first guy right here, 3 falls down in front. That's going to make 3/5 x squared. 3 falls down in front. There's already a 1/5 there. Technically, 1/5 times 3 is 3/5. Easy. New power is 2. All right, 2 falls down in front. 4 times 2 is 8. New power, x to the first. 2 falls down. 4 times 2 is 8. 2 minus 1 is 1. There's my new power. Lastly, the 1 falls down. Negative 8 times 1 is negative 8. My new power is 0, but again, x to the 0 is 1. So there is my derivative. 3/5 x squared plus 8x minus 8. How fast and simple. Very, very easy. Hope you believe me. All right, 2 more derivative rules that are I'm not going to really kind of show you proofs. This is just pretty straightforward. And that is the derivative of sine and the derivative of cosine. All right, so the derivative of sine is just cosine. Yeah, that's so easy, right? The derivative of sine is cosine. So if you have the function sine of x, and I say, hey, what's the derivative of sine of x? You'd say, the derivative of sine of x is cosine of x. That's one that you just kind of have to memorize, to be quite honest. All right, what's the derivative of cosine of x? Negative sine. It's that easy. Just got to be careful, though. You need the negative. A lot of kids forget about that negative. So if you have the function cosine of x, then the derivative of that function is negative sine of x. I mean, you can't make it easier. All right, so let's go ahead and apply those rules here. Now, the function is 2 cosine of x. Now remember, what do you do with a constant? Leave it. So the derivative, leave the 2. What's the derivative of cosine? Negative sine of x. So my final answer is negative 2 sine of x. Done. Come on, guys. I can't make it easier. But listen, so much easier than using the limits, right? All right, so next one, the derivative. What do you do with the negative 3? It's a constant multiplier. Leave it. What's the derivative of sine? Cosine. Done. Yeah, I know. It's like a joke, right? All right, now I could even use the addition and subtraction rules. So once again, I got 2 things. I got a 4x cubed minus 8 cosine of x. So to find the derivative, just do it piece by piece. 12x squared. I hope by now you're realizing, oh yeah, that's so, I can do that in my head. 3 falls down in front. 4 times 3 is 12. New power is 3 minus 1, 2. All right, what do I do with that negative 8? Leave it alone. What's the derivative of cosine? Negative sine of x. So I can clean this up because a negative 8 and a negative sine will make a positive 8. So 12x squared plus 8 times sine of x is my derivative. So easy. All right, what's the derivative of cosine of x plus sine of x? Once again, I'm going to use the addition rule. The addition rule says find the derivative of the first part, add it to the derivative of the second part, and you're done. So the derivative is going to be, well, what's the derivative of cosine? Negative sine of x. Plus, what's the derivative of sine? Cosine. Done. There's my derivative. I mean, literally, can't make this any easier. This is so unbelievably simple. These rules are really, really easy to use. And once you get the gist of them, it's so much faster than using the limits. All right, last problem here, and I want to show you this one because it's kind of a special problem. Now, as it currently looks, it's not a power function because it's not just x squared. It's x plus 3 squared. But listen, this problem is not easy. I take that back. I didn't mean to say that. This problem is not hard. It is easy, but you have to just do a little bit of working first. So I'm not finding the derivative yet. In order to make this easy, I need to multiply it out. So this is 4 times x squared plus 6x plus 9. That's just x plus 3 squared. Then I'm going to distribute the 4. I get 4x squared plus 24x plus 36. Now that I have it written as literally a power function, 4x cubed, another power function, 24x, and a constant, 36, now it's very easy to walk through and find the derivative. So sometimes the functions aren't set up for you to find the derivative very easily right away. Sometimes you got to do a little bit of work first to find that derivative. All right, now it's very easy to find the derivative. 2 falls down in front. 4 times 2 is 8. 2 minus 1, my new power is 1. 8x to the first. Plus 1, there's a 1 right here, falls down in front. 24 times 1 is 24. My new power is x to the 0. You can write it if you want, as long as you clean it up in a moment. And what's the derivative of a constant number like 36? 0. That was the very first rule we learned. And then obviously I'm going to clean this up. My final answer is 8x plus 24. Anything raised to the 0 is always 1, so that's why you just get 24. And there's my derivative. I mean, I cannot make this easier. These rules make finding derivatives so simple. So these are the basic rules. They work with plenty of functions, but there's a couple more rules to come. But for basic, simple polynomial type functions, these rules make finding derivatives, honestly, a snap. All right, see you in the next video.